Hey Course 3, we talked a lot about functions in Lesson 41. Today we're going to graph them. Remember the function machine illustration I used, that the book used, and I also mentioned that x equates to the input or the domain, which is the set of inputs. You put that into a function, which is a numerical machine. It should only produce one output for every input, and everything that pours out is called the range, the set of outputs. A function machine takes each element or member from the domain, which is that bucket, and produces one element for the range. You don't want to input one domain and get different ranges. It's okay if you put in different domains that end up with the same range, but you don't want to put in the same domain and end up with a different range. And a good real-life example is a checkout scanner. Is a function machine. The domain, the x value, is what the barcode tells it to cost. So you swipe it, beep. That's the input. The scanner processes like a function machine, and it gives you the output, which is the set of values are the prices. You should always get the same price when you swipe the same UPC. You should not swipe the barcode and then later that day swipe it again and get a new range unless there was some kind of a price reset or sale or something. So that's why a range should always have, a domain should always have the same range. But it's okay if you swipe two different barcodes and you end up with the same price. Maybe a book down one aisle and a toy down another are both $4.99. That's okay. The point is when you put in the range, the domain, I get these mixed up, the X, you swipe that book. You don't want to swipe it twice in a row and get two different ranges. That's not allowed. Now in example 1, the sign at the right describes a function, a rule, that relates hours parked to dollars charged. For the first hour, you pay $1. Every hour after that is $2 per hour. You'll never pay more than $15. It's open from 6 to 10. There's nothing overnight. So what is the domain? Domain is what goes in that determines the output. It comes first in a problem. It determines the output and not the other way around. The X is the time spent at the parking place. Your time there, how many hours between 6 and 10 that you're there. And since it is open only 6 to 10, there's only 16 hours you can be there. There's a limit of 16 hours. So the domain is 0 to 16. No time, all the way up to 16 hours, and then you're supposed to be gone. So we're not going to count those hours, any values outside of 16. Those amount of hours, that amount of time, determines, put it through the rules, the output, the range, the things that match up to the domain, and that's the price. And that's why you can only have one range for a domain. You don't want to park there for an hour one day and get charged $10, and then tomorrow park there for the same amount of time, the same domain, 1 hour, and get charged $20. That you can't rely on that. It needs a consistent rule. So the range is the amount of money you spend on that X, that time. Now this graph looks really different. I want you to take away one important thing from this graph. And it's that when you've identified your domain, your X, your input is always here on the X-axis. Makes sense, right? If it's your X, list it down here on the X-axis. Okay? And if it's the output, if it's the Y, let me get my color. There we go. If it's the Y over here, you put that on the up and down, right? And that's the change in dollars, the time. And this is a real funky looking graph. They're trying to show, okay, first hour, you pay $5, right? I think that's what it's set up here. No, $1. Sorry, that's what I meant, not $5. That's obviously 1. So after 1 hour, you've paid, it doesn't show it, but this is $1. Then after 2 hours, it jumps up to 3 because for every additional hour, it's 2 hours. Now, why is this an open circle that's right above? It's showing that you use this closed dot to determine what to pay at this set mark. At 1, you pay the closed dot. But then it immediately shifts at like 1 hour and 2 seconds. And they will nail you on that, by the way. Then it goes up to the open circle. Okay, there's no in-between amount. It's not a continuous graph. You will immediately pay the next amount the moment it changes. So it just jumps right up to here, and they show it by an open dot. And then for this period of time, for this hour, you're always going to pay the same amount. And then at this point, you're still paying this amount. That's the closed dot. But then the moment it switches, it's up here. And so instead of trying to get it right on the mark, they just put an open circle on the same line here. Okay, kind of makes sense. And it kind of looks like a step because it jumps from, one spot to another without any gap in between. It's not like a line on a graph that's continuous where, it doesn't look like that. Now, why do we have this line up here? Because it said there's a maximum of $15 charged, and we're at 15. So at 15, it levels off until the domain ends, which is at 16, we said. Okay, it takes time to decipher that, so it makes some sense. You have to kind of get that. We won't have as many graphs that look like that, but do try to understand it by reading through A, B, and C, thinking about the function. Pause and take time to think about it if you need it. We called it a step function. Here's an example of a continuous function, that perimeter formula. Perimeter is 4 times side. The domain is side lengths. I guess all positive real numbers, because a side length can be any positive real number. You can't measure a distance in negative numbers. And then the range here, they say, is all positive real numbers as well, because you're not going to end up with a negative if you've been using all positives to multiply. So the range and the domain are any number that's positive. So we create a table. We put in any value for S. 1 is always a good place to start. And then the range that comes out for that, the output is 4. We should call this the range, the set of outputs. And these are the outputs for each of these matching inputs. And every time you have 2, you should get 8. That's the rule with functions. When you graph these, you get something that looks a little more like we're used to. Notice we put the domain on this axis and the range on this axis. Don't forget that. That's one of the most important things to take away from today's lesson. Range goes on the up and down. All right, and then they set a way to graph this like we were doing in class. At side length of 1 here, you're going to have a 4 for perimeter. Perimeter is up and down here. When you have sides that are 2 times 4, you'll end up at 8. And so on, and this connects into this continuous line where it's not like this, like we did with the rule that we had last, but instead it's a continuous line, a continuous function. It begins at the origin, and all points are aligned in a linear fashion. So these are the features I've been saying indicate a direct proportion. We'll study what that means more in depth later, but that means yes, proportion. So you'll follow the directions here where you will make a table. And in this case, the table is decimals, because when you put in like 1 in this function, you get, 0.36 or 36 hundredths. So you might need to use a calculator. Then you graph it on an axis where you put domain here and range here. Then looking at the graph, does it satisfy the rules? And that's how you determine if it's a proportion or not. Does it follow those rules? Let's see what they do. They choose the values, they graph it. Its points are aligned, so it follows rule number 2, is it? I don't remember. But does it go through the origin? That's down here. No, it does not. It's going off this direction. And actually, I don't even know if it does go over here, because that implies negative numbers, and In this case, it might not include those. So no, it does not touch 0. So it's not proportional. The graph does not intercept 0. So it says the price range ratio is not constant either. So I guess that would be looking at whether you divide all of these. If you divide this, does it equal the same thing as this? And they say no. That's kind of hard to tell on a graph. So the origin's the big giveaway there. Let's do all of these. And that might be part of your assignment too, because I know that might take a little bit of time. Do your best, work together. A through F, because it's just that important. We'll see what kind of parts of the assignment we'll attempt. All right.